class, and welcome to lesson 3.6, approximating values of a function using local linearity and linearization. Our learning objective today is to approximate a value on a curve using the equation of a tangent line. So look carefully at the figure to the left. What do you see? Well, at quick glance, you could think this is a circle, but if you look a little bit closer, it is actually a 24-sided regular polygon. And in case you ever appear on Jeopardy, its technical name is icosicatera. I am probably butchering the name of that, but I did my best. Okay, so when the number of sides becomes this large, the length of the sides becomes smaller. So in calculus, the definition of a circle is simply a polygon whose number of sides approaches infinity and whose lengths of sides approach 0. Hold on while my pen gets back. So the above phenomenon occurs quite a bit in real life. Examine guardrails on the side of a curving road, and you will see that they do not match the curve of the road, but in reality are a series of straight line rails. Since the straight line sections of railing are numerous, they appear to curve. A wooden roller coaster is built the exact same way. It is far too difficult to create curved wooden side rails, so straight planks of wood are used, and when there are many of them, they can simulate the curvature of the coaster's hills. So linear approximations. So suppose we have a function f of x and its tangent line drawn to the point a f of a, as shown in your figure to the right. So again, here is my function, and then here is my tangent line. The equation of the tangent line, which we're going to call L of x, is given by the equation L of x minus f of a equals f prime of a times the quantity x minus a. And hopefully this does look familiar. It's very similar to this. And then if you wanted to get, or you could say L of x is by itself, and you have f of a plus f prime of a times the quantity x minus a. So if you go near x equals a, the function and the tangent line have nearly the same graph. So if you were to zoom in, like keep zooming in there, and I can't zoom too much because it will kick me out of this program, but you'll notice that both of them look the exact same. Okay, so if k were some x value very near to a, there would be very little difference in the values of L of k and f of k. In this case, we call the tangent line the linear approximation to the function at x equals a. Okay, so we're going to go ahead and do 3 examples. Example 1. So use the linear approximation for f of x is equal to the cube root of x at x equals 8 to approximate the cube root of 8.1. Okay, well, again, it says the keyword here is linear approximation. So I should be kind of thinking of this equation. So you have your L of x minus your f of a equals your f prime of a times x minus a. So first thing I'm going to do is I'm going to take the derivative, because I'm going to need that again, because you're thinking I need to get that equation of a line, should be thinking slope and derivative. Okay, so that gives me 1/3 x to the negative 2/3. Well, I'm going to need the slope at that specific point. So in this case, my a is 8. So f prime of 8. So again, plugging that in. Solving that, I get 1/12. Usually linear approximations are calculator active questions, so you will just want to plug everything in here. Okay, well now I actually need f of 8. So I'm just kind of checking my stuff off as I go here. So if I plug 8 into there, I get 2. So now I'm going to go ahead and write this equation. So as a slope intercept, so y minus 2, oops, equals my slope times x minus my value. Okay, now if I were to rewrite this in terms of L of x, y is L of x, so I could say L of x is equal, and if I'm solving for it myself, 1/12 x minus 8 plus 2. So now they actually want us to find, well, I want to approximate the cube root of 8.1. So I'm going to do L of 8.1. Again, just going to plug that in. When I plug that into my calculator, I get 2.008. And that is our answer. So linear approximation is nothing too bad, just kind of going through the steps with it. So let's go to example 2. So using a calculator, find the error in using the linear approximation to f of x equals e to the x at x equals 0 to approximate the fourth root of e. Okay, well, again, we're just going to start with the same process. I'm going to find the derivative. Well, the derivative of e to the x is e to the x. I want it at x equals 0, so f prime of 0, e to the 0 is 1. Okay, so now I need to find f of 0. Well, e to the 0 is also 1. So now let's go ahead and plug this into our point slope formula. So y minus 1 equals 1 times x minus 0. Rewriting this in terms of L of x. So I have L of x equals, well, that's just x plus 1. Now I'm going to go ahead and find L of 1/4. Okay. And why is it 1/4? Okay, so let's think about that. If you're not sure, remember e to the fourth root of e is e to the 1/4. So x is 1/4, in case you're wondering where that came from. So plugging it in, I get 1/4 plus 1, which gives me 1.25. Okay, so I have my approximation. Now I need to find the error. Okay, well, in order to find the error, your error is the absolute value of your actual value minus your estimated value. Okay, so our error is approximately, so our actual value, so if I take the fourth root of e in my calculator, I get 1.284, and I'm going to subtract my estimated value, so 1.25, and I get 0.034 as an error. Okay. Let's look at our last example. So super short lesson, which is nice because some of these lessons are longer, aka related rates. So last example, for the tangent line f of x equals x squared minus 3x plus 5 at x equals 4, to have an error of at most 0.1 when approximating f of 4 plus h, find the range of values for h. So again, what they're asking is what values of h are going to give me an error of at most 0.1. Okay, well, again, I'm going to start kind of the same process I did for example 1, example 2. So I'm going to find the derivative, if my pen wants to work. So if I'm looking at that derivative, I know that is 2x minus 3. Okay, now I'm going to find the derivative, okay, at, again, we're looking at 4. So I have f prime of 4 so that gives me 5. Now I'm going to go ahead and do f of 4. Okay, when I plug in f of 4, I get 9. So now let's write out our equation. So I have y minus 9 equals 5 times the quantity, x minus 4. And again, the 4, we're just taking it from there at x equals 4 here. Okay. So rewriting it for L of x, I get L of x is equal to 5 times the quantity, x minus 4 plus 9. Okay, well, now I have to go here. So I want to approximate f to the 4 plus h. So let's first figure out what that equation is. So again, that just means where I see x, I'm plugging in 4 plus h. Okay, so distributing here, I get 16 plus 8h plus h squared minus 12 minus 3h plus 5, which is h squared plus 5h plus 9. Okay, so we're going to keep that equation in mind. So now I want to use that a linear approximation. So f of 4 plus h, we're going to say is approximately L to the 4 plus h. So this is equal to 5 times the quantity of h plus 4 minus 4. So that just gives me, oops, and I forgot the plus 9. So those the 4's cancel, so I get 5h plus 9. Now, so I have these equations. So then in my next step now is I'm going to look at this error. So here's my error. I need that to be there. So the first thing I need to do is figure out what is the equation of my error. So again, it's my actual minus my approximate. Okay, so if I plug that in, I get h squared plus 5h plus 9 minus 5h plus 9, all in absolute value. The 5h's plus 9's cancel, and I'm just left with h squared. Okay, so I'm just going to erase this a little bit, just to get a little bit more room, because I wrote way too big. I blame my pen not working for a while. Okay, so I have the error. Okay, so now remember, we need the error to be at most 0.1. So what that means is I'm going to take the absolute value of h squared. So at most means that can be the biggest it can be, so it's less than to 0.1. Again, if I was looking at that, okay, so that means to solve for that, I'm going to take the square root. Well, when I take the square root, remember absolute value with that, oops, and this is less than or equal to, so I have negative 0.1 is less than h, which is 0.1, and then that's h squared, and then taking the square root, I get negative, oh, whoops, sorry. Okay, so this right here is actually going to be 0 is less than or equal to h squared, which is less than or equal to 0.1. Just remember, because I cannot take the square root of a negative number. So now I take the square root of both sides. Okay, well, 0, you get 0. And then technically the point, when you take that square root, it's going to be plus or minus 0.3163. So h can be anywhere from negative 0.3163 is less than h, which is less than 0.3163. So a little bit messy algebra right there, but hopefully not too bad. So any of those values of h, if I were to plug it in, so if I would subtract it from 4 or add it from 4, would give me an error of at most 0.1 when I would compare it. Okay, well that is it for 3.6. Have a wonderful day.